In this case, it's saying here, this is about different isomers of pentene. They want one isomer that's a branched chain hydrocarbon. Now they want a displaced formula. That means I'll just draw the rough structure first. That means what they want is 4 carbons in a chain and 1 branch. Obviously, you can either do that or do that. It doesn't really matter. They're the same thing from either side. What matters is where you draw the double bond. So you can draw it here, here, or here. Any of the 3 would be correct. So I'll erase this one and draw the molecule somewhere. So if I take this fellow, put it right here. Now I want 4 carbons in a chain and 1 branched. So 1, 2, 3, 4. Let's say this is my branch CH3. And the other guys would be hydrogens, 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 hydrogens. Let's make this the double bond. If I do that, then no hydrogen there, hydrogen here, and a CH3 there. But you could have put the double bond here, here, or here. It would have been acceptable. They're all correct. So this is, by the way, by name, this would be 2-methyl-but-2-ene. You could have made 2-methyl-but-1-ene. Or if you had put the double bond here, that would become 3-methyl-but-1-ene. If you want to make the skeletal for this, 1, 2, 3, 4, this would be it. And the second one is CH3. That's the skeletal version for this. The structural would be CH3 twice on a C with a double bond, CH, CH3. I'm just drawing you all. If they had not asked for displayed, all of them would have been acceptable. But obviously they asked for displayed, so I made this. But this is the structural formula and this is the skeletal formula. And we try to do that for every question as practice. Then it says pent-2-ene is one of the isomers of C5H10. So what's pent-2-ene? Means it's got 5 carbons and the second one is double bond. So if you make the double bond wahan, what you realize is that you got to be able to make the cis trans version. So you got to make it in this form. And in one case you put the CH3 there and the CH2 CH3 there, because that's what you have. CH3 on one side, CH2 CH3 on the other side. This I've made the cis, and this would be the trans. Obviously show the H and cis. Cis pent-2-ene, trans pent-2-ene. Then the next part of the question is about the 2 alcohols that make this. So understand that when this was a double bond, that means the alcohol that made this had a water molecule removed to make this double bond. That means that the water molecule would be around this double bond. So you make multiple alcohols that can make this alkene. For that you can put the OH on the left carbon, carbon number 2, and the H on carbon number 3, or the OH on carbon number 3, H on carbon number 2. So either it's pentane 2-ol or pentane 3-ol. So you draw those 2 out. So basically what they're saying is either the second carbon has the OH or the third carbon has the OH. But they want structural formula. So this will be CH3, CH, OH, CH2, CH2, CH3. The one on the right would be CH3, CH2, then CH, brackets OH, because OH always will come in brackets if it's branched, because there are 2 atoms in it. So this is pentane 2-ol, pentane 3-ol. If they are for skeletal 1, 2, 3, 4, 5, this would be OH, 1, 2, 3, 4, 5, OH. Pentane 2-ol, pentane 3-ol. इनमें से one of them is a chiral center, one of them is not a chiral center, because that's what I'm going to ask you ahead anyways. So which one is the chiral center? The one on the left here, because this one is not a chiral center because it has 2 identical CH3 CH2s, and the other carbons cannot be because they have multiple H's. Here also the carbons have multiple H's except for this one. So this one is CH, OH, CH3, and CH2, CH2, CH3. So this is the chiral carbon right here, because that's what they're asking ahead. What are they asking? They're asking that one of these alcohols exhibits optical isomerism. Yeah? So which one is this one? Pentan? To all. This is that guy. So what they're asking is draw the structures to show the three-dimensional shape. So what structures do you draw? The mirror image reflections. And so you can put the CH2, CH2, CH3 on top. CH2, CH2, CH3 on top. The OH here, the OH here, the CH3 here, the CH3 here, the H there, the H there. I tend to put the bigger group on top because it's just easy to write. Obviously this has mirror images, so maybe something like this. You draw the mirror plane to show their mirror images, to show that, but you have to draw the tetrahedral reflections of each other to show the chiral centers. These are chiral centers, and they wanted the three-dimensional nature of these eye structures. So you draw the mirror image tetrahedral structures to show optical isomerism. Isi ke marks hain. So after drawing this, the next part is pentooine decolors bromine but suggests the structure from an isomer of C5H10 which does not decolorize bromine. This information tells me that it must be saturated, which is an alkane. So the only alkane with an alkene formula would be cyclic alkanes. So either you draw the 5-carbon structural formula or the skeletal formula of cyclopentane. This is cyclopentane. A cyclic alkane has the same formula as a 1-carbon-carbon double bonded straight chain alkene. And then uske baad, the next part is polymerization. So for that, you should take out first draw the monomer unit, the CH3, CH2, and then H, CH3, H. So to polymerize this, H, CH3, C, CH2, CH3. This is 2 repeat units. If you ever need it, and obviously this is the monomer unit, I can cross that out, don't need it anymore. If you're looking to draw the, what you might call it, the structural formula for this would be, the first chain would be CH, CH3 in the brackets, then CH, then CH2, CH3 in brackets. That's one unit. Then the other one, similar. So one, and the second one would be CH, CH3, then CH, CH2, CH3. The skeletal will be easier. First double bond, second double bond, connected with each other with something like this. This is the first monomer unit, the second monomer unit. This one has a CH3 and a CH3, CH3, CH2, CH3, CH3, CH2. One monomer, second monomer. These are the bonds that connect the two monomers. Let me highlight them, maybe that will make it easier. This is one monomer, this is the second monomer. Connected only at the carbon-carbon double bond, carbon-carbon double bond. The rest of the stuff is this. CH3, CH2, CH3, CH3, CH2, CH3, CH3, CH2, CH3. I'm drawing this because more and more questions are now including skeletal formulae in the latest, because there's a trend in even books and everybody that they want you to be more accustomed to drawing skeletal formulae. So displayed, structural, skeletal for 2 repeat units. Because they specified 2 repeat units, you don't write any of the ends. It's just 2 repeat units. Now, let me, okay, can I erase this? I'm going to explain the skeletal formula again. Let me erase this. So, she's asking me to explain the skeletal formula again. It's this fellow. So now this is the main chain only. So let me highlight the main chain. This is your carbon-carbon backbone chain. Has 2 carbons from one monomer unit and 2 carbons from the other. So let's use purple for this carbon-carbon monomer unit. Let me thicken my pen also. So this is these two. Have to bond so that, the bond go down, they go up, they go down. So this goes down, and then has to be this connecting bond. Let's use, let's say, pink for this connecting bond. Then these two have to come into play. The second monomer unit. That is in black, so I'll do that. So I got the first monomer unit, second monomer backbone, just the carbon-carbon. This is this carbon, this is this carbon, this is right here, and that is right there. And this is bonded to, this is continuing, so we call them continuity bonds, if nothing else. So here, you can make this as a half a bond, because why smaller length? Because this is continuing again. So that's now the backbone made. Now all the branches, the first carbon has a CH3, so I make CH3. The second carbon has a CH2, CH3, CH2, CH3. The third carbon has a CH3. And the fourth carbon has a. Alright? Yeah. Always make the backbone first, and then everything else can sit. You can even label your carbons A, B, C, D, and then erase them baad mein. This is your one repeat unit, second repeat unit. Alright?